properties of exponents was the rule where you multiply two variables or more. So we saw this rule. This is the main one basically we're going to be using to multiply polynomials. What is this equal to again?
A plus B.
What exactly do you mean by that? So what is this equal to, the whole? What's the expression? Everybody, what is the rule here? The first rule of the exponents we saw last time. What is this equal to?
X on power
A plus B.
X to the power?
A plus B. A plus.
That's right. Right, so that's the first. That's the main rule. We saw the first one actually. This is basically actually a monomial times a monomial. If you look at it, you can think of it as a monomial times a monomial. There could be more variables here and more variables here, just like we saw last time. There could be numbers also, or coefficients. That's the simplest one. So basically monomial times monomial. We're going to see how also have to multiply maybe a monomial by a binomial, maybe a binomial by another binomial, and so on. The rule is basically this. We're going to add more terms. That's going to be the same rule again, this one. So we saw something like this last time. Let's take, for example, this, that's a monomial, right? And we're going to times it by, we're going to call this, so monomial basically times a monomial. And maybe another one here. For example, -1 and 5. And then again, exactly like we did last time. What is this equal to if we multiply these? What's the product of these two monomials, everybody?
30.
5 multiplied 6.
Okay. All right. What else?
And x is a base, and we multiply the powers, and y multiply the powers.
We don't not multiply the powers, but
7x.
We add the powers.
add
Yeah.
them. That's right. X to the 7. What else?
And 2. Y2.
Y2. That's right.
Not multiply, combine. Sorry.
That's right. And we then combine 3 and -1. That's 2. So basically it. That's the product. We just multiply the monomial by a monomial. Notice this monomial by a binomial. So my monomial times binomial. 2x to the third, for example, power 4, and this would be multiplied by a couple of terms. You don't need multiplication there, but a couple of terms or a binomial inside. Let's say 5x to the fourth, and maybe another one here. Let's see. Okay, so this is basically the distributive property we talked about. So we need to do two multiplications here. So first we're going to multiply these two, and then the other two. So it's going to be basically two of these. We're going to have two of these multiplications here. So we distribute it. So let's multiply these right away. That would be
10x. 10x 4.
Okay, so 10x power 4. So again, we have x3 and here.
Yeah, y8.
That's right, x1 and the y's together. y4 would be y8. So that's the first product. Then repeat the same thing. Again, we're distributing, so we're going to multiply these two. -6, okay. And
Then it's going to
x is together.
x8
X to the power 8, that's right. Finally,
and y6.
y to the power 6. That's it. We're done with this multiplication. It could be many more terms here. It should always be the same thing. Basically, it's this rule. And in addition to this distributive property, we have more than just two terms, or a monomial times a monomial. Let's see. Let's do another one, maybe with, say, a monomial times a trinomial. It's going to be pretty much this, maybe with another term here. It's going to be 3 multiplications instead of 2. So 3xy, for example, something like this, and we're going to times this by some trinomial. Okay, and there's some powers here. Powers could be in a sign, as we know. They're basically real numbers. So we're actually, since we said polynomials don't have negative powers, as we said before, so polynomials don't have negative powers. So let's stick to just positive powers. Okay, so we're going to distribute all this.
Gonna be
Yes.
12x power by 5.
That's right. So we're going to do basically this 3 times. So this monomial times, you can think of it as a, let me remove this minus here, it's not a minus. So this is basically a monomial times a trinomial. Trinomial. And again, just going to multiply these. So the first one is
The 12x.
24. Okay.
Okay. Gonna be 5x power by 5.
That's right. And the y's together.
Why
Your
7?
y is 7. And again, we're going to go to the next one. So the second multiplication, so 3 multiply -2, that's -6.
6.
And x times x will be
3.
x3. And finally,
y9.
y9. That's right. And the last multiplication. So yeah, as you can see, we have 3
Positive
multiplications here.
15.
15, okay. So 15,
x3.
that's right. x1 times x2, that's x3.
And y10.
Okay, that's right. y10, the last 2 terms, last 2 variables, 5 and 5 will be y10. So it's, again, as you can see, it's pretty simple. We use the main rule here, the first one. Later, we're going to learn how to go back from here to this. So this is simple, straightforward, basically distribution or multiplication. We're going to learn in the future, very important topic called factoring. That's when you basically take this and go back to this form. That's another topic, which is, like I said, important. That's basically it. Now we're going to do 2 by 2. We're going to do a binomial by a binomial and see what we get. But before that, any questions, everybody, so far? Everyone in the room? Are you guys okay? Any questions? Okay, please let me know if you have any questions, everybody, in a moment. And again, this is pretty simple. We've done this already a couple of times at least with the exponents and the properties. Now this is where it gets a lot interesting when you have a binomial times a binomial. And this we're going to be using quite often. So basically, something like this. Okay, that's a binomial, and we're going to times that by another binomial, maybe 5x minus 4. Okay, so how many multiplications are we going to have in total here?
4.
4, exactly. So when you multiply here 1 by 1, like we did earlier here, 1 by 1 multiplication, we times 1 by 2, 1 by binomial, 1 by 2, so you expect 2 multiplications. When you times 1 by 3, 1 times 3 is 3. You times 2 by 2 terms, so we expect in 4 multiplications. You may reduce that, you may combine like terms, and you might be less than 4 terms, but there's got to be 4 multiplications. Same way if we times in, for example, a trinomial here, by a trinomial will be 3 times 3, which is 9, or a trinomial by a polynomial with 4 terms. 3 times 4 will be 12 multiplications and so on. We call this, some of you know it as the FOIL method. When we have 2 by 2, we call it the FOIL method, simply the distributive property. The acronym for it is the FOIL method. All it means is that we multiply. We basically distribute everything. So we start with the first term here, and you times that by both the terms of the other polynomial. So this will be multiplied twice. Okay, so 1 times it by these 2. So once we finish with this term, we go to the next and we do the same thing. So we'll take that term, multiply it by this one, then also by this one. So we can have a bunch of multiplications, 4 of them, like we said. But for the first time, I'm gonna write them all out before we multiply, just for the first time. But in the future, you may just multiply right away and write the result. So the very first one would be 2x multiply 5x. Okay, I'm just gonna write all the multiplications first. Then we have 2x times -4. First, get the sign. So we have a positive times a negative. So it's going to be a negative. Then we have 2x times 4. So after this, so as you can see, we're done with this one. We're going to go to +3 and do the same thing. So +3 times
It's 2x
5.
times 4, not 5.
Oh, times 4, that's right. Times 4. So 3 times 5 is going to be a positive. Times 5x. And finally, positive again, times a negative. Again, make sure you get the signs right. That's important when combining terms and so on. So it's going to be -3 times 4. So these are the 4 multiplications we talked about. 1, 2, 3, 4. Again, in the future, you may write the result right away. You could just say 2x times 5x. You may just say 10x in the second right away. You may skip this step. Or if it helps,
So
if it helps. Yes?
we multiply by always with negative, right? So we
No, it depends.
5x minus 2x 4.
Yeah,
So a negative between. So it's the rule, right?
No, it depends. They could be both negative, it could be both positive. So it just times whatever we have. So the first one is positive times positive. Second one is positive times a negative. That's why we have a negative. This one is positive. And then the last one was positive times a negative. That's why we have negative. But again, you may have 2 negatives here or 2 positives. Okay, so we have 2x times 5x, then 2x times 4. It's going to be -8x. And then the next one, positive 15x. And finally, -12. So again, we could have gone from here to here directly instead of doing this. But again, if it helps you clearly see the terms, see the powers, maybe you want to write them out first. If that's easier for you, that's fine. Or you may just write the answer here. Now we're going to combine. What do we combine here to simplify? What are we combining here? Everybody, how do we simplify this?
It goes 10x.
You combine the x like minus
Plus 7x.
yeah,
That's
gonna be
right.
like
These are like terms.
7x plus 7x minus 12.
That's right. So always simplify your answer when it's not always possible, but if you can, always simplify. If you have a different power, for example, 3 here, you wouldn't be able to simplify. But depending on what you multiply, you may get like terms, you may not. So as you can see, we have 3 terms left. We had 4 multiplications. We had 2 by 2. This is 4 multiplications. That doesn't mean you're going to end up with 4 terms. Maybe 4 terms here, but it is possible to combine them into 4 terms or less. So when you times 2 by 2, expect to have 4 terms or less. It could even be 2 terms sometimes. We're going to see an example here where we could end up just with 2 terms, even though when you multiply 4 by 4. Let's actually do that one right now. This is an important one. When multiplying polynomials, let's say 3x. This is an important one when you have something like this. Basically, it's the same terms, but the sign changes. The sign is different. but it's the same numbers. So this is a special one. Actually, based on it, we're going to conclude the formula. We're going to conclude a formula that we can do quickly without doing all these steps. Without doing all these 3 steps, we can actually do this in one step using a special formula. You may know it. Some of you may know it. So let's work it out first like this, and then we're going to conclude the rule that we can use every time. Only if you have the same numbers, but with different signs. Different, not the same signs, different signs. Something special is going to happen. So let's do this.
3x minus 5, all of it in the power of 2, right?
Close enough, not exactly, but close enough. So let's multiply it and we'll see what we get. So 3x times 3x, that would be, everybody, 3x times 3x will be
9x in the second.
That's right, 9x is second. So, okay, so we did this. Now we're going to do this.
It's
3x.
gonna be like
Plus 15x.
plus 15x
That's right. 15x. What else?
minus 15x
That's right. Now we're going to multiply the -5, so negative 15x. And
minus
finally,
5.
exactly, negative 25.
So it's gonna be like
Alright.
9x squared, x was on 2, you know,
Okay.
minus 25.
Exactly. So these two, as you can see, they're opposites. They cancel out. They're gone. We're only going to have this term left. Okay, and the other term. So that's why I said this is a special formula. So those two are gone because of the opposite signs here. So these only cancel if you have opposite signs. If it's the same sign, they would stay. They would be either both positive or both negative, and you would combine them, and you will have something like this. But if you have opposite signs here, those middle terms cancel out, and it goes right away. So if you look at this here, how can we jump from this to this right away in one step without having to go through all of this? Look at the terms. So look at that 3x, look at that 5. How do we directly get from there to here?
It is 3x in the power of 2 minus 5 in the power of 2.
That's right. So you take, because it's the same numbers, take the first term and square it, minus the other one also square. That's it. When you have something like this, we can do it in one step. You can even just write the squared form right away. You can just say 3x to the second is 3x times 3x, which is 9x. You can also just write, instead of writing 5 to the second, you can just write 25. That's the same answer we got here by distributing, but feel free to use this formula whenever possible. You don't have to memorize it, but this one is helpful. We can use it for multiplying. We're also going to use the opposite of it when we go backwards. Sometimes, again, we need to go from here back to this. Again, factoring. So this one is especially important because it helps with both. It helps with multiplying and also with factoring in basically in right away in seconds. It doesn't take too long. Okay, so that's a special formula. Let's write the rule now. So generally, if you have, again, something like this, a minus b times some a plus b, right? Again, the numbers are the same and the signs are opposite. What is this equal to in one step?
X was on 2
Mhm.
minus bx was on
That's
2.
right. That's right. We just take those and we square them. That's all. And it's a minus in between, not the plus. I mean, they have to be opposites here, but we take the plus instead for this reason, because if you distribute it, it's going to be like this. You're going to cancel the middle terms and you're going to end up with these two. So that can be done again in one step. So that's important. Okay, this is the most important one. There are a couple more, but there are a couple more rules, but you don't need to memorize them. Okay, there's a couple more rules like this, but this is the most important one. The other ones you don't have to memorize, just it may confuse you. Just simply distribute your polynomial like this in 2 steps. Distribute it, combine like terms when possible. Okay, so again, this is especially important. And again, it only works if you have a minus and a plus, and you have pretty much the same terms inside. The only thing that changes is the sign in between. So don't confuse this with, for example, let's say x to the second, what x, let's say minus 5, and x minus 5. Okay, so this is not going to be like this. It's not going to cancel out. You will have something inside. You will have something stays inside. It's not going to cancel out.
It's gonna be like
Mhm.
A square plus B square, right?
Something like that. There is a formula for this, but I don't want you to get confuse this rule with this rule. There's a formula for this. There's a formula for when you have a plus and a plus, but I don't recommend you memorize them. If you know them, feel free to use them.
The second one, x minus 5 whole in the second, right?
Which one?
The second one.
Here?
Yeah, is x minus 5 whole of it in the second.
If the formula would be, you would square this, then
Yeah.
you times both of these by 2 times this, and you square the last one. Again, if anybody knows that formula, feel free to use it. If not, I would suggest you just distribute. It doesn't take that long. So x to the power x is x to the second, x times -5, that's -5x, and then -5x again. And finally, positive 25. So as you can see now, these two don't cancel out. They don't cancel out because the same sign, they stay here. We're going to combine them. Unlike here, they cancel out because of the opposite signs. So that's why this formula is useful, because we know things will cancel out. So we just do it in one step. We just keep basically this and this, the first and the last ones, the first and the last multiplication. The outside and the inside, they cancel out. So we have the firsts and the last. That's what we keep. And of course, this, when we combine these, you're going to get x to the second minus 10x plus 25. Okay, so there is that. Or if it's a plus here, you would have a plus. It's both pluses here will be plus 10 x instead of negative 10x. Okay, so that's binomials. There's another thing also you may have with polynomials. Let's say you have 3x plus 2 or maybe 4 to the second power. Basically, we have a binomial to the second power. How do we multiply this? How do we multiply?
It goes 3x, 9x in the second.
Okay. Or
Plus,
if you break it down first, if we think about breaking it down.
it's 3x whole of it in the second.
Okay.
Plus 2.
Okay.
That
Plus
multiplies 3x. That multiplies 4.
Okay. So you're using the formula, right?
Second. Yeah, I'm using the formula.
That's good. That's good. So if you're using the formula, that's fine. Or another way of doing
you can divide it 3x plus 4, which multiplies 3x by 4.
Exactly. So it multiplies itself. So whenever you have something to the second power, for example, if you have 5 to the second power, basically when we break it down, 5 to the second, it just means 5 times 5. Anything to the second power basically means that thing times itself, the base times itself. The base here is this. The base here is this whole thing, this binomial, to the second power. It means we're going to multiply it by itself. Or if the power is 3, for example, you would have another multiplication. If it's 4, one more, and so on. So basically, when you have second power, especially if you have the second power, you break it down first. This is the expanded form we talked about before when we discussed the rules of exponents. This is the expanded form when you expand something. Basically, multiply the base by itself as many times as power. Once you break it down, we're back to this. Once you break this down, we're back to this. This formula is not going to work when you break something down like this, because every time you're going to have the same sign. either both pluses or both minuses when you times something by itself. So this is not going to work for this, unless you use the other formula, which I didn't write. If you know it, you can use it, but you don't have to memorize it. This is the important one. All right, so the rest is simple. We're just going to distribute and combine the terms. Okay, so what do we get from here? What's the first result or multiplication? First multiplication
9x
here.
squared, 9x squared plus 12x plus 12x plus 16.
Okay, 9x squared.
Mhm.
All right,
Plus
what else?
x
Plus 12x.
plus 12x plus
That's right,
16
plus 12x again if you multiply those two. Finally,
plus 16.
16. That's right. What else?
So 9x squared plus 24 plus 16.
That's right. So these combine because the sign is the same. Those we combine it. So x to the second, 9x to the second plus 24, x plus 16. And that's pretty much it. Again, it might be a minus here. If it's a minus, there's going to be two minuses here. And
Wait,
these
so
will
you
be
see,
two
I have
minuses.
a question.
Mhm. Right.
You see 12x, 12x, you combine those, why it don't have a square? Because 2x, it's 2x there.
Okay, because it's not a multiplication. The powers add up when you multiply two terms.
Okay,
When
okay.
we
I
combine
got
them,
it.
we only combine the coefficients. So this is just an addition.
I understand.
Mhm.
Okay.
Right, so as you can see here, the multiplication of polynomials, everybody, is pretty simple. So it's the main rule every time. And you could have multiple terms, multiple variables. Expand your multiply first, expand it, combine like terms. This is again a useful formula. You can do this in one step quickly. Let me give you another one of these. Let's say you have x to the second, not x to the second, x minus 3, x plus 3. So it kind of looks like that. You can do this again in one step, exactly one step. What is this equal to if you apply the formula? Everybody, what is that equal to? Just apply this
X
formula.
squared
Okay.
and 3 squared.
And the
Minus
sign in
3
between.
squared.
That's right. So x squared minus 3 squared, which is 9. So just take first one, square it, minus second one also square. That's it. So that's done in one step. Again, you don't have to do it like this for a long way. This can save you time. If you forget the formula, that's fine. You can always distribute. Always distribute like this, combine like terms and see what you get. So again, this is important. For multiplication, again, we'll see later that sometimes we need to go back. We'll have something like this and we need to turn it into a multiplication. So this formula will be useful. What else? Any questions, everybody, about any of this? Everyone? Let me know if you have any questions. This should pretty much be it. Let me know if you have any questions. If not, I'll give you a few problems to practice on.
I have a question.
Sure.
If there was 2 in the parentheses with
Okay.
the square outside of the parentheses,
Well,
how do you solve that?
give me the whole expression. Give me an example.
Okay, so 3x
Okay.
plus 2
Okay.
parentheses,
Like this.
and then another open parentheses,
Okay.
right? With 3x.
With some other power, right? Or
Yeah. Plus 5.
plus 5.
Yeah, and square outside the parentheses.
And so this one.
5, yes.
Okay.
Will you see that?
They do the square.
All right, so we would do this one first, just like this. Break it down first. Okay, so when you break this one down, so you're going to end up with something like this. Then you're going to multiply this by what you get from here, which is going to be 3 of them. So it's going to be a long multiplication, but it's not complicated. It's pretty simple. Okay, I won't give you something like this. Usually it's going to be something pretty simple. So break this down first, turn it into that. Then you're going to have 2 by 3, 2 binomial by trinomial. You're going to have 10 multiplications. It's going to be a long multiplication, 10 of them. But just like this, instead of having 3 here or 4, you have multiple different, 10 multiplications, 2 times 5. Not actually 2 times 5, 2 times 3. Going to be 6 multiplications. Okay, but don't think about something complex like this. I don't think you'll see something like this in the homework. You may see 3 here, but that's about it. You may see 3. In this case, you can have 1, 2, and 3 parentheses. Okay, any other questions, everybody? Everyone? If not, let me write down some problems. So again, just like we just did, it's your turn now to try things on your own. This is where you test yourself and you see if you got it, practice it. All right, so let me give you, just like we saw previously, so it's -7. I'm going to multiply that first by another polynomial. Another monomial, like this. And then probably a monomial by a trinomial, let's say 5 plus Great, 1 by 3, and a couple binomials here. Let's see. So next plus 2, 4 plus 3. Second, finally, x plus 5, or x plus, not 5, 6, x minus 6. That's special, okay? This is a special one. Again, think about the formula. Think about the formula I gave you. It could make it simple.
I'm sorry, Professor. I'm back. My phone died. I mean, my computer died. I'm on my phone.
It's okay. So there's some practice problems here. Monomials, trinomials, binomial, and another binomial. Maybe even one more. Something like 4x plus 3. And maybe 2x to the third minus 5. So the power here is 3. Okay, so should be pretty simple. The first few, you can do those in one step, most of them. This take you a couple of steps. All right, that's it, everybody. So give you a few minutes to work on this. You may take a short break also, maybe a couple of minutes, then start the practice. Still have time. All right, so I'll see you back in a few minutes and we're gonna go over this together. Then we're gonna talk about the homework or if you have any other questions. I'll be right back in a few minutes.
Okay.
Hello again, everybody. Let's go over these problems. Are you guys done? Everyone, have you finished? Hello, everybody. Can you hear me?
Yes.
Yeah, we can hear you.
All right.
Yes,
Because, okay. Are you done with the? Should be done by now, right? This practice. All right.
Can you hear me?
Not too clearly, no. I can hear you, but sound far.
I'm sorry.
Just
On my
get close
phone.
to the microphone.
I have in my earpods.
Okay. All right, so everybody, let's go over these problems. What do we get from here?
Minus 35 x 6 y 4.
Okay,
35.
that's right. So minus 35, x 6, and y 4. The power for this is 1, y 4. Very simple, one step. This we have a distribution. Okay, so we're going to distribute this. We're going to have 3 multiplications. That's the first, what do we get from the first multiplication?
10
Okay, so 10.
10x 7y 4.
Okay, and also we have a 1 here, so it'd be 4. Okay, that's the first multiplication. We have 2 more. This one would be
Plus 14x 9y.
that's right, plus 14.
14.
That's right, x to 7 and y to the 5th, right?
Y, 6.
X
No, wait.
To the 5th, okay, and the
Y.
last one, last multiplication, also this times this will be
14x
Wait.
9. No, it's 9.
14x
Is that X
x.
X7, X9?
Let's see, the
That is
second
it.
one.
It's
Mhm. 9, right?
14x9
Mhm.
X.
Okay,
Y5.
I was about to
And what-
say that. I'm getting confused.
It's
okay,
6x10 7y.
okay, x10 and
7y.
y to the 7th, okay. Okay, so again, you can do this in one step here, one line. We distribute, as always, combine the powers. Basically, we had 3 of these in this one. All right, the next one here. What should we do first?
It's what is it?
We have
It's gonna be
7x.
like it's gonna distribute it like it's gonna be x
49
plus
X squared.
7x plus 3
Okay, so let's break it
by
down first.
7x plus 3.
That's right. So we break it down, basically times it by itself. And then we're going to distribute it. Distribute it. So using the distributive property or the
49x.
FOIL method.
It's gonna be 49x
49
squared plus
That's right.
42x plus 9
Plus 21x. Okay.
plus 42x, not 21. Oh,
21. So
the total is 49x squared
no,
plus
let's do it
42x.
step by step. Let's distribute it first.
Okay.
Then we'll combine the two. So 21x, what comes after that?
Plus 21x
21x again.
plus 9
Okay.
plus 9.
Plus 9. Now we're going to combine like terms if we have any. What do we combine? What do we combine here?
49x squared plus 42
Combine the 21.
x
I mean, the
plus
21
9.
and 21.
Okay, so basically combine these, so that's 21. I mean 42.
42.
Combine these two. Plus 9. That's our final answer. It's no more like terms. All right, on to this one. This can be done. Can we do this in one step?
I'm like x squared minus 6
squared
minus
36.
36.
That's right. X squared minus 36. Always use the formula for things like this. Basically, you take the first one, you square it, and you take the second one also squared, but with the minus in between. Okay, it's got to be a minus in between the two. Very quick. Okay, don't waste time on it like this. Don't do all this to it. This is a special one. Last one here. You're gonna have to distribute it just like we did here, and see if we can combine any like terms. So what do we get here first? From the first multiplication.
We got 8x exponent
8x what?
4.
8x to the
4.
4th. That's right. 8x to the 4th because we have a x1 here. We
We got
add the 2.
negative 20x
Okay, that's right. Negative 20x.
plus
6x to the third.
x 3
Whoever has background noise, please mute your mic. I hear some noise in the background.
plus 6x exponent 3
That's right. Multiply these two plus
minus
6.
16
Okay.
minus 15.
Finally, that's right. The last multiplication, positive 3 times negative 5. Any like terms to combine here?
No.
That's right. There's no like terms. This is power 1. They're all different. That's fine. That's not a problem. It's not always possible to have like terms. You may rearrange these from the highest to the lowest. You may move this next to the 4 so you can have your powers in a descending order, but it's not a big deal. It's still pretty good. And that's how you multiply polynomials. This is, again, pretty straightforward when you multiply, but remember, we're coming back to this with an important topic. As I said before, we're going to learn how to go back, how to turn this back into a multiplication, turn this back into this, and so on. That's, again, what we call factoring, and it's very important. We're going to get back to it sometime later. Okay, any questions, everybody, about the practice or anything else we've done today?